So this is the next we want to discuss how can perform the matrix multiplication using dynamic programming approach. Okay. Now we are discussing this problem. Okay, so first of all you should note that there is an equation to calculate the cost C of ij. So C means cost, C of ij. We will use a data structure cost C. Okay, C. Okay, we'll use a data structure C, and initially this matrix store the cost. Store the cost. So the entries in C of in this matrix C is calculated using this equation. Okay, C of ij is equal to min of I less than or equal to k less than or equal to j. Then there is a bracket. Inside that bracket, we will write C of ik plus C of k plus 1 comma j plus t I minus 1 into tk into dj. D means dimension. Okay, D means dimension. This is the general equation for calculating the cost. Okay, so this is a general equation for calculating the cost and the parameters of I comma j. Okay, so here there is a matrix C. Okay, hello Anaka. Okay,
Sir, okay.
issue no. Okay. So this is the equation for there is a matrix C and there is a matrix M. Okay, there is another matrix M, and this is the equation for calculating the cost. Okay, C of ij, and you should study this equation. Then the question is perform A1 into A2 into A3 into A4. The size of A1 is 3 by 2, size of A2 is 2 by 4, size of A3 is 4 by 2, size of A4 is 2 by 5. So here we are assigning this variable D0. Okay, 3 is D0, this is D1. Okay. So these are same. Okay, these are same. So this is also D1. Okay, these are same. So this dimension is considered as same D1. Okay. Now this is D2. These are same. Okay. These are same. So these are equal. D2, D2, and this is D3. Okay. This is D3. Since these are same, what we will do? This is also D3 and this is D4. Okay, so these are the variable dimension variables used in this method. Okay, so there are four matrices and the dimension is given. Then what you want to do is that assign a dimension variable to each dimension. Okay, so starting from D0. Okay, D0, D1, these two are same. Okay, so D1, D2, D2, D3, D3, D4. In this way, we will assign the dimension variable. Then there are two matrices. One is M and another is C. Okay, one is M and another is C. Okay. One is M and another is C. So what we want to do is that we want to calculate the entries in the matrix C. Okay. We want to calculate the values of the entries in matrix C, and we want to update the M matrix. There are two matrices are there. Using, okay, this is the basic process. Okay, just we want to calculate the entries in matrix C and M. Okay, so initially you can note here these all are zero. Why? Because this is cost of 1, 1. Okay, this is cost of 1, 1. Then this is cost of 2, 2. This is cost of 3, 3. This is cost of 4, 4. Okay, so in this case it is all zeros. Okay, these are all zeros. Then what we want to do is that we don't want to consider this. Okay, this is not an issue here. Okay, because if we calculated this one, this will be same, this one. Okay, this will be always same. So we don't want to bother about these entries. Okay, next what we want to do is that we want to calculate this one. Okay, so how can calculate this entry? Okay, how can calculate this entry? That is the question. Okay, I want to calculate the value in this entry. Okay, in this entry. How it is possible? So we are focusing that case now. Okay, so which is that entry? So we can use this equation C of I comma j. Okay, so which is that entry? Basically this entry is C of 1, 2. Okay, this entry I am focusing. Okay, this entry C of 1, 2. Okay, so this is the general equation. Min of 1, I is 1. Okay, you can note here there are two variables I and j. This is I and this is j. Okay, this is j. This is j. So I and j are there. So the equation will become equation. You can note here. This is the equation. Okay, what is I? What is j? We can note. Then we want to just substitute the values in this equation. Okay, that's all. So here I is 1 and j is 2 and k is here. Okay, the value of k lies between 1 and 2. Okay, 1 less than or equal to k less than 2. So in this case, k will take only one value. K is equal to 1. Only one value is can be assigned for k, which is 1. Okay, so we will consider the case k equal to 1. Then the equation becomes c of 1 1 plus c of 2 2. Okay, this is the general equation. Okay, this is the general equation. Just we are substituting the value of I and k in this equation. Okay, so this is the general equation. You can note here. Okay. So this equation, in this equation I am assigning values. Just to understand the procedure. So it will become C of 1 1 plus C of 2 2 plus D 0. Okay, D 0. That is D I minus 1. You can note here D I minus 1 is there. When I is equal to 1, it become D 0. Okay. When I equal to 1, it become D 0. Okay. Just observe di minus 1 is there. Here I is 1. In this case I is 1. So D becomes D0. Okay, D0 into D1 into D2. Into D1 into D2. That is just we are substituting the values in this general equation. Okay, that's all. Okay, so I is 1, so D 1 minus 1 is D0, K is 1, D1 into DJ, J is 2, so D2. Okay, so D0, D1, D2. Okay, so we got an equation in this way. Then what we will do? We will find the values of C11. What is C11? So it is basically a small subproblem. Okay. The time to solve that subproblem is in this entry. You can note here. This is C11. So it is 0. Then C22. This is C22. It is also from this matrix we will get it is 0. Next, what is D0? Already I told if a matrix is given in this way, this is D0. D0 is 3. Okay. D0 is 3. This is 3. And D1 is 2. D1 is 2. Okay. D1 is 2. D1 is 2. Okay. So 2. Then D3. What is D3? D3 is 2. Okay. So, sorry, D2. Sorry, this is D2. Okay, D2, and D2 is this one. D2. D2 is 4. Okay, so this is 4. Then what we will do? We will perform this operation. Then here K will take only one value in this case. So we need to we want to take minimum of only this case will come. So after evaluating, the value become 24. Okay. So what we will do? We will enter here. This is 24. Okay. By using the similar procedure, we want to calculate all the entries. Okay. So now this is okay. Next we want to calculate this one. Okay. How can calculate this one? Same equation we want to apply. One more thing. So I entered 24 here. Then what I will do is that here another matrix M is there. Okay, we want to update M also parallelly. we want to update M also. Okay. So we updated 24 here. Then we want to update this matrix M. Okay. So which means here for k equal to 1, we selected this solution. Okay. Sometimes there will be k equal to other variable, k equal to 2 and so on. K equal to 2 and so on sometimes. Okay. But here only one solution is there. That value of k is equal to 1. So what we will do here, 1, 2, here we will put 1. Here we will put 1. Okay. So we updated this to 24 and here we put 1. Why put 1? Because this solution is taken k equal to 1. C of 1, 2. C of 1, 2. This entry or this entry, 1, 2 entry is filled with 1. Why 1? Because k equal to 1 cases we considered. Okay. That is why we put 1 here. Okay. Next, what we will do? Next, we will try to calculate the value of this. Okay. You can note the order. We are calculating in this way. Okay. You can note here C of 1, 2. Next is we are calculating this one. Okay. Not this one. Okay. Try to understand that concept. After calculating this, we should calculate this one. Okay. Else the problem we can solve it, but it will take more steps. Okay. So after solving this one, we should consider this one. Okay. So then we consider C23. We will solve the using the same concept. 2 less than or equal to k less than 3. In that case also, k will take only one value. K is equal to 2. Okay. C22 is 0. C33 is 0. Then D1, D2, D3. Already we know from this. From this already we know. Okay. So we will multiply that. Okay. We will multiply this and we will get an answer 16. Okay. So what we will do? We will update 16 here. Okay. We'll update 16 here. First we updated this one. Then we update this one. In parallel, what we will do? We should update this one. This entry. This is 2, 3 entry corresponding to this matrix M. What will be this value? Here, K, you can note here, C23, K is equal to 2 is considered. The value of K is 2. So what we should do? We should fill this with 2. Okay. We should fill with 2. You can note here. Okay. You can note here. Okay. So this is the approach. That is, we want to fill these matrices in this way. Okay. So we finished this one, this one. Next, what we will do? We will not take this one. We will take this one. Okay. This one. So you can observe here why we are taking this one is that 2 minus 1 is 1. 3 minus 2 is 1. 4 minus 3 is 1. Okay. In that sequence, we will take. We will first process all entries with the difference 1. Then we'll go to the next and so on we want to process. Then we will get the solution quickly. So now we are going to consider 3, 4. Okay. So by using the same approach, we can solve C3, 4. and we will get value 40. Okay, so we will fill the value 40 here. In parallel, what we will do, we will update this matrix. Okay, so you can note here, uh, you can note here, this is one. So here C34, we want, I didn't return the steps, but you should use the same logic. Then solve it. Then you will get a value C23. Sorry, it is C23. Okay. Next we want to find this value C34. Okay, C34. So 3C34 will be 40. Okay. Then what we want to do? We want to fill 40 with 40, and we will update here 3. Why 3? Because in this case, while solving, we may select k is equal to 3. Okay, that is the reason. Okay, so in the we updated there. Then what we will do, after completing these three, this one we will take this one, which is that entry C13. So the difference of dimension is 3 minus 1 is 2. So we should consider this, then next this. Okay, so now we are taking this one, C of 1 3. Okay, C of 1 3. What is C of 1 3? This is the general equation. If we put in the equation I is equal to 1, J is equal to 3, K will take the value between 1 and 3. Means K will take two values. You can observe here. K is equal to 1, K is equal to 2. In the case K is equal to 1, the equation is like this. Okay, D0, D1, D3. Then what is C of 1 1? It is 0. So what is C of 2 3? C of 2 3 is already solved and stored in the matrix. Okay, you can try to understand the dynamic programming approach. We will solve a problem and store the solution somewhere. So in the future, we will use that solution. So that idea we are using here. Here, C of 2 3 16. Where we get 16? Okay, in this matrix, C of 2 3 is 16. It's already solved. We will use that value here. Okay, so this is 16. Then D0, D1, D3 already we found. Then solving, we will get 28. Similarly, we will consider the case K is equal to 2. Okay, in the case K is equal to 2, this will be the equation. Okay, this will be the equation. So D0, D2, D3 is already fixed terms. We want to find out this. What is C of 1, 2? So we can check our table. C of 1, 2 is 24. Okay, C of 1, 2 is 24. So that problem is already solved and its value stored in somewhere in that matrix. So we want to reuse that value. So it is 24. Okay, this is 24. And C of 2 3 is 0. Okay, C of 2 3 is 0. Okay, I think sometimes it will be C of 2 2. Okay, anyway, C of 2 2, I think. Okay, and this is C of 2 2. So its value is 0. It is 2 2. Okay, sorry, this is 2 2. C of 2 2 is 0. Then solving, we will get 48. Okay, then what we will do is that which is the minimum. Okay, we want to take the minimum. Okay, we want to take the minimum. So minimum of 28 comma 48 is 28. So C of 1 3 is 28. Okay, C of 1 3 is 28. Okay, C of 1 3 is 28. So in parallel, what we want to do, we want to update this matrix. Okay, this matrix. want to update this. We want to update this one. Okay. So here I put 1. Why? Why? Here you can note k is equal to 1, k is equal to 2. Which one I selected? 28 I selected. That is k is equal to 1 is selected. Okay. So that is why I am putting 1 here. Okay, I put 1 here. Okay, in that way we should put the value or fill the matrix M. M. Okay, so we done that step also. Next, what we will do? We will try to calculate this value. Okay, so what will be the value? So in the same way we can solve it. C of 2 4 is 36 and k is 3. Okay, just try to do yourself. Okay, next, after completing that, what I will do? I will take the last this element C of 1 comma 4. Okay, we will apply the same concept. You can note the equations here. Just try yourself. So k is equal to 1, one case, k is equal to 2, another case, k equal to 3. We will get the values of these from the previous tables. Okay, so I substituted this value and I got this value 86, 124, 58. So which is the minimum among it? 58. 58 is the minimum. Okay, so for what value of k it is minimum? K is equal to 3. Okay, so what I will do? I will update 58 here and 3 here. Okay, try to understand how I am filling M. Okay, so here 58 is the minimum. At that time k is equal to 3. The value of k equal to 3. So I filled 58 and 3. So I processed all the elements in the diagonal entries above this matrix. Okay, I processed all the elements. Okay, then I got so here you can note here the minimum cost. Minimum cost means minimum number of scalar multiplication needed is 58. Okay, we need a minimum. So what we want to do is that from this matrix we should select the maximum value. That should be the minimum number of scalar multiplication needed. So in this case the optimal solution is 58. That is minimum 58 multiplication is needed. So this is dynamic programming approach, and for solving chain matrix multiplication problem, just by using this procedure we will get the minimum cost or optimal cost needed to multiply the matrices. So here I got a cost. Then what about this? What is the use of this one? So I got the cost only. Okay, the cost is 58, but in which sequence I can multiply, which order? In order to find the order, we will use this matrix M. Okay, so what we will do is that initially there are 4 matrices A1, A1, A2, A3 and A4. Okay, A3 and A4. Okay, initially there are 4 matrices A1, A2, A3 and A4. So what we will do is that there are 4 matrices 1, 2, 3, 4. Okay, so consider 1, 2, 3, 4. Initially there are 4 matrices 1, 2, 3, 4. Then we will check this entry. Okay, 1 to 4 entry. 1, 4. We are considering 1 to 4 matrix initially, and the value here is 3, which means we should put a parenthesis in this position. Okay, here we will put a parenthesis. I put a parenthesis here, and here also I want to put a parenthesis. Now next, this is a singleton matrix, so we don't want to bother about this. now we want to consider 1 to 3 matrix. Okay, you cannot consider 1 to 3. So what is 1 to 3? Here you can note 1 to 3, here it is 1. Okay, so where we will put the parenthesis? We will put the parenthesis here. Here we will put a parenthesis. So we'll put a parenthesis here. Now only one element, this is another. So the parenthesis order will come in this way. Okay, next what we will do? Next, this is on singleton, this is singleton. Now the remaining is this only. Okay, now we consider 2 3. That matrix is 2 3, 2 A2 and A3. So 2 3, where we will put the parenthesis is 2 3. We will put the parenthesis at the position 2. So if we put a parenthesis at the position 2, then which means we will group this together. Group this together. Then this will be the sequence. If we perform the multiplication in this sequence, we will get uh, optimal cost 58. So this is about the dynamic programming approach used for uh, chain matrix multiplication. Okay, so next class we will try to discuss the algorithm. So the method is important. I think in the university exam also a problem will be given to you, and you are supposed to answer the problem. You are requested to answer that problem. Okay, so this is about this topic. Okay, please try to study this topic. Okay, so please give your attendance. Okay, thank you, thank you.
സാറെ റിവിന്റെ ഡാറ്റ പാക്ക് തീർന്നുള്ളൂ. ഹലോ സാറേ.
Itu cara cara bahasa ya, bukan kita bahasa.